We have here the multiplication property as one of the properties of divisibility. This tells us that for all d and a integers, if d divides n, then a times d, or the product of ad, it divides a n. It's called multiplication property because if you have this expression, you could just simply, if you're going to multiply the same constant to d and a, it doesn't change the relationship of d and n. Now, to show this, let us of course go to our definition of divisibility. If you have d, what do you call it, one divides n, okay? If d divides n, then you could come up with an equation like this. N is equal to d, let's just simply use c, where c is any integer. Okay? Now we could express d divides n into this equation where c is any integer. This tells us that d is a factor of n. Okay? That's why d divides n. Now, if using this equation, n is equal to dc, if you're going to multiply a on both sides of the equation, so we have here dc times a. Okay? Of course, it's an equation. It doesn't change its value, so it's still true. Now, from here, I would like to use the commutativity of this. Okay? I'm going to use here, again, I'm using commutativity first because these are two different factors. Okay, so don't be confused with that. It's just commutativity. Then, I will be using the associativity of multiplication. Now, take note of that. I'm using commutativity and then associativity here. Now, from here, we are able to express that an is just a product of ad and the same integer c. Take note that our end goal is this. We would like to have an expression separately, the ad and an, and we are done with this. Now, from here, going back to definition of divisibility, since we can establish that ad is just a factor of an together with c, we can now say that ad divides an. This ends the proof for this property as shown in these given situations. This is again properties, laws, and theorems. Please subscribe now.